Hello everyone. We have a question of the modulus inequality, and the question is finding the solution of this particular modulus inequality. We have two different methods. One is by the basic algebraic method and the other is graphical method. So we would be discussing both of them so that you could get a very clear-cut idea how it works. So let us start with the algebraic method. It is very simple. Just square both sides of the inequality sign, and instead of this modulus sign just use the round brackets as we have done. 2 square is 4, and definitely 3x minus 1 with a square is basically a minus b whole square, and definitely that is equal to a square minus 2ab plus b square, and x plus 1 whole square is according to a plus b whole square is equal to a square plus 2ab plus b square. After that, multiply this 4 and just move all these terms on the other side, and after that simply add up the like terms. That means x square with x square, x with x, and constant with constant, and rearrange them, and we can see we have a proper quadratic standard form, which is 35x square minus 26x plus 3. A proper standard quadratic form we have. So the next step is that finding the critical values. Finding the critical values means finding the values of x when the value of y is 0, because based on that finding the set of values would be easy. So for finding the critical values, that means when y is 0, finding the values of x, in other words the x-intercept, we will use the quadratic equation, and by using the quadratic equation and using the values of a as 35, b as negative 26, c as positive 3, placing them in the quadratic equation, solving them, and getting the two values of x, which are 3 upon 5 and 1 upon 7. The coefficient of x square is 35, positive 35. That means the graph would be a U-shaped. And the two critical values, or in other words, the x-intercepts are 3 upon 5, 1 upon 7, and 1 upon 7 is 0.14, 3 upon 5 is 0.6, and definitely 1 upon 7, which is 0.14, is less than 0.6. That means 1 upon 7 is less than 3 upon 5. So 1 upon 7 over here, 3 upon 5 over here. The next thing that we have to observe is that the given quadratic equation is less than 0. Less than 0 means negative, and negative means the negative value of y. So we need those values of x which would definitely give a negative value of y, and if we just observe the graph, we can see that if we take any value of x greater than 1 upon 7 and less than 3 upon 5, definitely it would result in a negative value of y, and definitely that is our solution, because the given quadratic equation is less than 0. That means y would be negative, and for that we could easily say that the set of values are all the values which are greater than 1 upon 7, because they are giving a negative value of y, that means less than 0, and all the values less than 3 upon 5. So finally we have written x is greater than 1 upon 7 and x is less than 3 upon 5. So these are the set of values. In further questions, we would come across those questions where we would have a modulus sign on just one side of the inequality. In this question, we had the modulus sign on both sides of the inequality. So when we would be discussing those questions where we have the modulus sign on just one side of the inequality and the other sign would not contain the modulus sign, all this process would be same till here, but at the end there would be a slight change in the observation and the working, so that we could get the actual and the required set of values. So at that time I would be comparing, when we would be discussing those questions, I would be comparing both the questions where we have the modulus on both sides and modulus on just one side of the inequality. As I said in the beginning, we have another method also to find the set of values, that is a graphical method. So let us discuss the graphical method. For graphical method, if we just look at the question and the inequality, we can easily observe that on both sides of the inequality we have two linear modulus equation. So definitely when I said that two linear modulus equation, so if we draw the graph would be a straight line for both the linear modulus equation. So we would take y is equals to 2 modulus 3x minus 1 and y is equals to modulus x plus 1, and we would take some values, as you can see over here we have taken both of them and made them equal to y. So just take some dummy values of x like 0, positive -1, positive -2, positive -3, or positive -4. Don't go for big values because definitely then it would be impossible for you to sketch the graph or draw the graph. So just take some dummy values so that you could easily make the graph. Now the thing that is to be observed is that the modulus, which is also called the absolute value, is never negative. So a minimum value that a modulus condition could have is 0. So that means this modulus can have a minimum value 0 or a positive value, and when multiplied with 2 will always be positive. That is why you can see we have observed that if we take x negative or 0 or positive, but the y is always positive in both the cases. Over here the y is always positive, no matter you take x negative, 0 or positive, but the y is always positive. Y will never be negative because the modulus can never be negative. If we just look at the graph, we can also observe that the graph is just touching the x-axis and then bouncing back. The graph is never below the x-axis, because if it is below the x-axis, definitely the value of y would be negative, and from the two modulus equation we know that the y will never be negative. That is why when we know that the y is never negative, the graph will never be below the x-axis. It will just touch the x-axis and bounce back. And when I say when it touches the x-axis, that means over there the value of y is 0, and I told at that time a minimum value a modulus sign could have is 0 or positive, never negative. So I have used two different colors so that we could easily observe the graph and make the judgment what will be the set of values. For the first modulus linear equation, which is 2 modulus 3x minus 1, I have used green color, and for the second I have used red color. Based on all these points, I have drawn the graph, and we can see the two graphs intersect each other, and basically these two intersection points are basically the same intersection point that we got over here, which are 3/5 and 1/7, and definitely 1/7 is less than 3/5, so 1/7 is over here, 3/5 is over here. After looking at the graph, we can see that in some conditions, like if we take any value less than 1/7, we can observe that this green line is above the red line, and if we take any line greater than 3/5, it is observed that the green line is above the red line. And if we take any value in between 1/7 and 3/5, it is observed that the red line is above the green line. Now we know that the green line is represented by this inequality, which is the first one. This is representing the green line, and this is representing the red line. So green line is less than red line. By looking at the graph, just look at that particular area where the green line is less than the red line. And definitely after looking at the graph over here, the green line is above the red line, that means greater than. The green line is above the red line, that means the green is greater than red. But over here the red line is above the green line, that means the red line is greater than green, or in other word, the green line is less than red. So green line is less than red means this is representing green is less than this red. So after looking at the question and after looking at the graph, now it becomes very easy for us to analyze that the area which is the set of values for the given condition, is basically the area which is greater than 1 upon 7 and less than 3 upon 5, because in this area this red line is above the green line, or in other word, the green line is below the red line. That means the green line is less than the red line, and green is this one and this one is less than this one, and definitely that is a question. So finally the set of values are all the values greater than 1 upon 7, x is greater than 1 upon 7 and less than 3 upon 5. You can use any of the method in your paper, but I would suggest that go for an algebraic method. There is no like hard and fast rule that we cannot use that. It is totally up to you, but definitely my recommendation is go for this particular method.